Pulleys and wedges, type 5, 3 accelerations. So in 1992, we had a light inextensible string passing over a fixed pulley under a movable pulley B of mass m, and then over another pulley C. And we have a mass m is attached to one end of the strings and a mass 3m attached to the other end. So we're told the system is released from rest. The inextensible string means that they're not elasticated, so we don't have any simple harmonic motion going on. And again, we have to show in the first case the diagrams of the forces acting on the three masses. So I'm going to draw my diagrams and set up my equations at the same time, but obviously for part one you're just looking at drawing the force diagrams. Okay, so let's take a look at the overall picture first before we draw our separate diagrams. So what do we reckon is going to happen here? So if we're not sure which way these are going to move, because we don't know what the masses are, we know this one is a mass of m. So if we don't know whether m is going to be heavier than the combination of m and 3m, or is b going to move down and the other two move up? Is 3m going to move down and m moves up? So we're not sure what the relationship with m is, the capital M is with the small m's, until we get to part 3, of course, okay? If you get the direction wrong, then obviously your acceleration would work out to be negative, which means that it would actually be moving in the opposite direction, okay? So what I'm going to do is I'm going to say that this one is going to move in a downward direction, and I'm going to say the other two are moving in an upward direction. Now, when the string passes underneath our pulley, our relationship is that the acceleration of B will accelerate with half the sum of the other two. And again, that's because the string is going under the pulley. So when it moves, if it was to move upwards, say for instance, then it's freeing up string on both sides, so the other two will go down twice as far. Okay, so that's the key to our question here. So what are the forces acting then? Okay, so we have our weights, so gravity acting on each pulley. And so capital M and small m. We always have to be careful with these ones when we're given capital M's and small m's to make sure that we're using the right letter. Then we have tension, so it's one string, so common tension. So tension always acts away from our object. And we have no other forces then acting on our pulleys. Okay, so now we have our overall big picture. Let's draw the separate diagrams to get our marks for part one. So I'm going to look at the first one there, which is our our pulley, what's it called? Sorry, so it's A. So we'll call it A. Okay, so if we look at A, the forces acting on it, we said are tension acting up and gravity acting on it in a downward direction, which gives us mg, and it's accelerating up. Okay, so I'm going to set up my equations to look at my net forces at the same time. So my leading force, I've said it's accelerating up, so the leading force will be tension. The opposing force will be the weight, and therefore the net force will be equal to mass times acceleration. So that gives me T minus mg is equal to ma, and therefore T is equal to ma plus mg. So that'll be the first equation. The second one is B, and the force diagram for B is our pulley. So we have two tensions, we said, acting up away from the object. And the weight acting down. And that's capital mg. And we've said that it's going to accelerate in a downward direction. So therefore the net force is going to be, the leading force is going to be the weight acting down and the tensions acting up. It's equal to the mass times the acceleration. So in this case, the weight is capital mg. I have two tensions. My mass is capital M, and be careful here, my acceleration is the letter c. Okay, and I'm going to say, but C is equal to A plus B over 2. So therefore, mg minus 2t is equal to m times A plus B over 2. And if I multiply out my brackets there, then I get 2mg minus 4t is equal to capital M, capital A. So capital M times A plus capital M times B. And therefore that gives me 4t is equal to 2mg minus MA minus MB. So this is my second equation. And so I'm just going to label that part 2, obviously. So my diagrams are down the side for part 1, and part 2 is my equations here on the right hand side. So my third particle that I'm looking at there then is 3m, which was called... Oh, sorry, actually, I just noticed there it's the pulley is A and the pulley is C. So I shouldn't have called that A there at the start. Just let me change that. So I'm just going to call that the M particle, the pulley B, and then the 3M particle. Sorry about that. Okay, so the force diagram for the 3M. So we have the tension acting up, and the weight acting on the particle down is 3mg. And we said it was accelerating up. And again, if I look at my net forces, then, well, if it's accelerating up, the leading force is tension minus the opposing force, which is the weight, is equal to mass times acceleration. So the tension is T, the weight is 3mg, the mass is 3m, and the acceleration is b. Okay, so again, I'm only ever writing out this first equation just so you can see what are my leading forces. Don't take it literally, these equations here. This is just what am I subbing in. I'm looking at tensions and weights and masses times acceleration. Okay, so therefore this is equation 3. All right. So what we want to do then is we want to prove that the tension T is given by this equation here. Okay, so we're trying to get this out. So again, I'm not going to focus too much on getting that out until I get towards the end. Instead, what we're going to do is we're going to try and see, can we get our relationship between all the tensions. Now you can see there that there's no A, there's no B, and there's no letter C in here. In other words, there's no accelerations in this equation. So basically, if I look at equation 1, it has acceleration A in it. If I look at equation 2, I've already subbed in the C with this equation over here on the left. The C is equal to A plus B over 2. And that leaves me with A and B in the equation. And then if I look at equation 3, well, let me just rearrange that there to get T in its own. So T is equal to 3mg plus 3mb. So I'll just change that to 3 there. So what we want to do is see, can I use those 3 equations to get rid of those letters A and B? So what I'm going to do is I'm going to get A and B in its own, and then I'm going to sub it into equation 2. So I'm going to sub A and B into equation 2 because equation 2 has A and B in it. So therefore I'm going to take 3 and I'm going to rearrange that to get B on its own. So that would be 3mb is equal to T minus 3mg. And therefore B is equal to T minus 3mg over 3m. Okay, let's get rid of that squiggle there. And if I go back to the first equation here, I'm going to take that and I'm going to get A on its own. So that's going to be MA is equal to T minus mg. In other words, A is equal to T minus mg over m. So I'm going to sub A in here in 2 and B in here in 2. Okay, so what is that then? So that's 4t is equal to 2mg minus capital M times T minus mg over M minus capital M times T minus 3mg over 3m. Okay, so I have fractions here, so I want to get rid of my lowest common denominator there to make it a bit easier. So we're going to multiply everything across by the lowest common denominator there, which is 3m. And if I multiply across by 3m, that gives me 12mt is equal to 6m capital M G minus 3 capital M T plus 3m capital M G minus M capital M T plus 3m capital M G. So we always love these questions where we've got lots of m's in it. Okay, so again, just be careful, as I said, that it depends on your writing, how neat you're going to be, that your small m's and capital M's don't merge into the same letter and cause confusion for you. Okay, so what do we want to do next? Well, we want to see, can we go back to this equation here? Well, I'm clearly looking to get G on its own. I have T, capital M, and 3M, so small m. So I have capital M, small m's, all my A's and B's and C's are gone. So I have all the correct letters here in this equation, so it's just a matter of doing a bit of algebra. So let's see, can we tidy up? What are our like terms? So I have small m, capital T, and I have no other likes there, so that's going to stay as 12mt. I have 6 small m, capital Mg. Well, clearly I have that and that and that will add together. So they are like terms, so that's 6 and 6, which is going to be 12m capital Mg. And then I have 3mt and an mt, so I can add those two together, and that's minus 4 capital MT. Okay, so now I want to get the G on its own. So if I get the G on its own, I'm going to bring that to one side. So we have 12mg is equal to 12mt minus 4 capital MT. Okay, and I want to then divide across by my m. Now if I go back, let's just see, they've taken out t as being common. So I can see I have t out being common there. So I'm going to get G on its own. So taking t out as being common, which leaves me with then 12m minus 4 capital M divided by 12 small m capital M. Okay, so we're almost there. Homeward stretch. So all we have to do now is just a little bit of fractions. So you can see they've separated out this fraction into 1 over m and 1 over 3m. So in other words, here this can be written as two separate fractions inside the brackets there. In other words, 12m over 12m capital M minus 4 capital M over 12m capital M. So all just algebra to finish off here, okay? So we have 12 goes into 12, m goes into m, 4 goes into 12 3 times, and m goes into m. And lo and behold, we've done it. We've got 1 over m minus 1 over 3m. Yay. So it's always a good feeling when you get these out. And we can see that's that one done. Okay, so part 3 then is basically saying show that if m is equal to 3m, then pulley B will remain at rest. So if pulley B is going to remain at rest, well, that means that it's not accelerating. So this value here for C must be equal to 0. And that means the other two are going to remain in motion. So in other words, if C is to remain at rest, that clearly means that the 3m is going to accelerate in a downward direction and A is going to accelerate in an upward direction. Okay, so what are we going to do for this? Okay, so we're given that capital M is actually equal to 3m. So therefore, if I sub that into my equation, T, so we have, instead of 1 over m, that's going to be 1 over 3m, plus 1 over 3m. So that gives me T times 2 over 3m. In other words, the tension is equal to 3 mg all over 2. Okay. So therefore, if I look at acceleration A, so I'm going to sub t into A. Well, what does that give me? Well, equation A, if I go back to it, was t minus mg over m. So t is 3 mg over 2 minus mg over m. So all those m's are going to cancel. And that leaves me with 3g over 2 minus g, which in other words gives me an acceleration of g over 2. And then if we do the same for b, so in other words we're going to sub t into the equation for the acceleration b. And if I go back there, what was b? Well, we said b was this up here on the right hand side, so t minus 3mg over 3m. So therefore that's going to be b is equal to 3mg all over 2 minus 3mg. That's divided by 3m. And of course 3m is going to go into 3m, which is going to go into 3m. It's common there on the top and the bottom, leaving us with g over 2 minus g. And therefore that gives us the minus g over 2, as we kind of predicted that if c was going to stay at rest, this one would accelerate in a downward direction rather than the upward direction as predicted. Okay, so we just make a note of that. Negative I actually accelerates. Up, not down. Okay, and therefore, well, what's c? Well, we know c, as we said, is equal to a plus b all over 2. So hence, if I put in for my a, I get g over 2, and I put in for my b, I get minus g over 2, divided by 2, and what's that equal to? 0. So if the acceleration for c is 0, we say, i.e., pulley B remains at rest. While m and 3m move. Excellent. So a very similar, if not identical, question came up in 2007 as well. Okay, so looking at the marks breakdown for this then. If we were to base it on our 2007 question, it was 30 marks, 10, 20, 30 marks, yeah. So we had 30 marks. And we had 10 for our diagrams. So let me just go back there actually. So we have 10 for diagrams. We had 5 for getting the first two equations and 5 for getting, so 5 for the two equations. So 5 for the two equations and then 5 for getting, subbing into t. 5. So 5 and 5. And then we had 5 for getting out our g. So 5, 10, 15, 20. And then we had 5 for showing that C was at rest overall. So let me just double check that. We had 5, 10, 15, 20 and 30. Perfect. Okay.